Hello, everybody. So, welcome to the 5 elements Math Hub channel for SAT. And this is the question, SAT style question that we have. We are supposed to figure out the value of x for which the function given here reaches the minimum value. Now, the first method is substitution, where we can directly substitute the values of x that are given here in the options. Of course, very time consuming. So, I will not recommend this. The second method is Desmos. So, in Desmos, what you can do is you can quickly input this equation y equals to x minus 6 times x plus 8, and this is the graph that you get. You may have to scroll down the graph a little bit till you reach the end of the parabola. Now, why this is a parabola? Because f of x is basically a quadratic function, and if you expand f of x, what you will get is that the coefficient of x square is going to be 1, which is positive, and hence it is going to be an upward opening parabola, hence it has a minimum. So you go to the bottom of the parabola and then you click on the bottommost point, which happens to be the vertex of the parabola. So there we have it. You have -1 comma minus 49. You can check this in Desmos for yourself. So -1 turns out to be the minimum point, right? -1 comma minus 49 is the minimum point, and -1 is the x coordinate, which is exactly what we want. -1 is my answer. Simple and straightforward using Desmos, not very time consuming also. The third is a very unique method to quadratic equations, to parabolas. So I quickly observe that 6 and -8 are going to be the roots of the parabola. Basically, 6 comma 0 and -8 comma 0 are the points through which the parabola is going to pass through the x-axis. I'm going to take their middle point, the midpoint of 6 comma 0 and -8 comma 0. The distance between them is 14. Midpoint should have distance of 7 units. From -8 also 7 units. From 6 also 7 units, exactly in the middle. So that lands me at -1 comma 0. So -1 is my answer. How do I go about doing this? Let us derive it in the next few minutes. So the method 3 is having the knowledge of parabolas without using Desmos. So I have y is equal to this, ax square plus bx plus c. Whenever I have it, I have a parabola. The parabola may open upwards or downwards depending upon the sign of a. If a is going to be positive, the parabola will open upwards. If a is going to be negative, the parabola will open downwards. Right? So I have an upward opening parabola here because coefficient of x square is 1, which is positive. And as I told you earlier, the parabola will have its roots will go through the x-axis at 6 comma 0 and -8 comma 0 because of this equation, right? So let us quickly plot those points. All right, what do I have next? I have the distance. Distance between -8 comma 0 and 6 comma 0 is going to be 14 units. If I divide 14 by 2, I have 7 units. What use is the 7 units? This orange color highlighted line that you see, this is of the length 7 units, 14 units, I'm sorry. And the midpoint is going to be 7 units from 6 and 7 units from -8. Okay. And where does that land us? That lands us at exactly -1 comma 0. Now, if I draw a line through -1 comma 0 parallel to y-axis till it cuts the parabola at some point, that point has to be the minimum, right? Why? Because of this important note. For any parabola, the maximum or minimum of itself of the parabola appears on its vertex, right? Why is that? Because the parabola is symmetric in nature. Whatever is happening to the left hand side of the uh, vertex of the parabola, the same thing will happen on the right hand side, right? The parabola is symmetric. So that is the reason why this blue colored point that you see on the parabola, which is also laying on the yellow colored line, is basically going to be the minimum. And anyway, we care only about the x value. So the x value is going to be -1, hence -1 is the answer. Thank you. And if you have any comments or any suggestions to make this better, please put your comments below. Thank you.